All right, here we go. So we're still on chapter 3. We're gearing up for logic, right? We're going to jump from. Oh, there's Janice as well. Welcome. I'm glad there's at least two people here. We're gearing up to jump into propositional logic, which is sort of the intimidating part of this course. And I set it up where I skip a few chapters because those chapters don't actually help get us ready for propositional logic. This stuff gets you ready for propositional logic. And I'm even sort of teasing out a few things already ahead of time so that now when we get done with this, and I'm not entirely sure if I'm going to do assessing long arguments. I might just be done with argument patterns and then go to propositional logic. I'm gonna see, but I'm trying to make it as painless as possible, right? To learn how to do logic. And so it actually helps a lot to do what we're doing today, looking at argument patterns, because that's a lot of what logic is about. And so that's where we're at. No, that's not the right one. We want to go to this planet over here. All right. Just a really quick, basic, very basic review, just so you can connect all the dots and keep the thread, right? Critical thinking. Why do we care? Well, you've got that map in your head, right? That map guides all your behavior. Right? It tells you where to go in life. So we should care about that map, right? We should have a good, accurate map that's reliable, that doesn't let us down. And so rather than let the world write your map for you, you are writing your map, right? And so one major way in which you are a caretaker of your map is to make sure that when you believe something, you've got good reasons to believe, right? And as soon as we get to that part, right, should I believe this? Are there good reasons for it? Then we're dealing with arguments, right? Reasons for belief, premises, conclusion, right? That's the same thing. So always make sure you're connecting this back to the main idea here, that you are taking care of your map and you want to make sure to add accurate beliefs or beliefs that are more likely to be accurate. And so for that, you have to evaluate arguments. You have to evaluate whether or not the reasons are good enough to accept that conclusion and whether or not those reasons are true, right? So you ask the logic question: if the premises are true, does the conclusion follow, right? Would the conclusion have to be true, like in a deductive argument, or is it highly, highly likely to be true, where it might as well be true, but there's just a smidgen of doubt, right? Like in an inductive argument. Right? That's the logic question. And then you ask, are the premises actually true, right? Okay. Now we can jump back into where we actually are. So I've given you examples of valid deductive arguments, right? We looked at that when we looked at the difference between inductive and deductive. Even though I just said it, I'll just repeat it, right? In an inductive argument, if you have a really good inductive argument, that means the truth of the premises uh, supports the conclusion in such a way that the conclusion is probably true, right? In other words, if the premises are true, the conclusion is highly likely to be true. That's in a good inductive argument. In a good deductive argument, if the premises are true, then the conclusion has to be true, right? It logically cannot be false if the premises are true. And so I've given you lots of examples of arguments like that, that are called valid. In a valid deductive argument, the truth of the premises guarantees the truth of the conclusion. Right? So, for example, this one goes way back to the first week, right? If there's a cat in the house, I will get allergic. There is a cat in the house. If both of those premises are true, then that conclusion logically has to be true as well, right? So it's valid. Right? We know that. Are the premises actually true? That's a different question, right? That's the truth question. But we can ask the logic question even if we don't know if the premises are true or not, right? Uh, Maybe you don't know if there's a cat in the house, right? That's a possibility. But still, you can still see the logic of this argument, right? You can understand that if both of the premises were to be true, the conclusion has to be true. Right? So this is a valid deductive argument. What the deductive argument should be in order for you to add that conclusion to your mind map, right, it should be sound, right? Not only should it be valid, the premises should actually be true. Right? So if you've answered the validity question, you're not done. You still then do have to ask, well, are the premises actually true? Because otherwise you have no guarantee that the conclusion is true. Right? Okay. So here's an example, and notice this kind of structure that it has. If this, then this. Well, this is true, so therefore this must be true. If I'm hungry, then I will have a snack. I am hungry, therefore I will have a snack. Very straightforward, right? And I think even people who are kind of allergic to logic will have an innate sense of, yeah, this makes sense, right? And in that sense of it makes sense, right? That's your logic detector. You can spot validity at least sometimes. There's something kind of funny that I was thinking about, that in order to understand logic, right, which we're going to get into, we're really going to teach you how to do logic. In order to understand logic, you already have to understand logic. It's kind of unfair because you have to have a logical mind that understands how things fit together and why something would follow and why something shouldn't. So it's kind of a funny thing that before you can even understand logic, you already have to kind of understand logic. Anyway, hopefully everyone sees that this is logical, right? And hopefully you can even see that maybe I'm lying, maybe I'm not hungry, right? But it's still a valid argument because the conclusion follows logically from those premises. There's a philosophical one, right? Philosophy is full of arguments. Right? Philosophers can't do experiments like scientists do, right? But they can present arguments, and that's sort of like providing evidence in a scientific context, right? If all events are determined by the past, then we have no free will. All events are determined by the past, therefore it logically follows we have no free will, right? Again, all the examples are toy examples, right? So it's up to you whether or not you agree with the truth of the premises, right? You know that it's valid. You know that if both of the premises are true, that conclusion is inescapable. But, you might have a problem with either of those premises. They might not be true. So don't get too worried, right? If you are really worried that, oh no, this proves there's no free will. Well, no, it doesn't. It doesn't. This is just a valid argument. Whether or not it's sound, that's still up to you to evaluate. Do you actually accept both of those premises? If you do accept the premises, then you should accept the conclusion. But they all share this basic format, right? If A, then B, A, therefore B. And A and B there, they are what we're going to call in logic variables, right? A and B or P and Q, right? Any letter that you use that's to stand for a true or false statement, right? That makes it a variable. Just like in math, you have variables that stand for numbers. And here we have variables that stand for statements that can either be true or false, right? So if A is true, if statement A is true, then statement B is true. Premise 2 says statement A is true. Therefore, what follows logically, statement B must be true. Even this one, it doesn't say if then, but you should be able to see that even though people express arguments in different ways with different words, the same logic is at play, right? So this argument says, when Judy drives her car, she's always late. Since she is driving a car now, she will be late. Even though it doesn't say if then, and it says when, right? It's still the same type of argument. It's still something like that, right? Because you could even rephrase it and it would mean the same thing as it did originally, right? So if we assign a variable, right, to each of the statements, the simple statements inside the big complex statement, Judy is driving a car, Judy will be late, then we could put it into that format. Right? So if you see that earlier one where it says if A, then B, A, therefore B, Well, here we've just taken the simple statements of when Judy drives her car, she's always late, right? Go, Judy drives a car, she's always late, and just put it into that format. If Judy's driving a car, then Judy will be late. Judy is driving a car. Therefore, it follows logically Judy will be late. Here's another example. I'm giving you different examples so you get a good idea for this because it's not always presented in this formatted way, right? Out in the wild, as I like to say, when people present their arguments, they're not necessarily going to say, here's premise one, here's premise two, right? They'll just say the whole thing. Fido must be warm-blooded because Fido is a mammal, and if Fido is a mammal, then Fido is warm-blooded, right? That's all just like one big kind of a run-on sentence, right? But the structure is still there, right? You still have two basic simple statements. Fido is warm-blooded. Fido is a mammal. And then you can take those simple statements and put them into that premise, conclusion format. Right? Just like that. So you have to always be kind of careful, right? Because this is all just one sentence, and it is a statement, but it's what you call a complex statement. Right? It's a complex or compound statement because it's one big statement with all sorts of little statements in it, right? Well, really just two little statements, but then it's just configured in all these different ways, right? But connecting it with an if-then statement, but it's all one big argument as well. So we're saying these are the premises and this is the conclusion. But you can lay it out in this streamlined way, and then you can really see the logic of it very well. So there's a certain skill that's required in hearing someone's argument, reading someone's argument, and then reconfiguring it in your mind in this sort of premise, conclusion format, right? The beautiful mind thing, right? You should be able to like take what you hear and then make it into these kind of diagrammatic, this very streamlined way of presenting the argument in a logical way. And so any argument at all with this format is valid, right? So if you have an argument like this and you've made sure that the premises are true, then you have a sound argument with a true conclusion. And so this can actually help you, right? It does not matter. Appreciate this for a second. It does not matter what statements you put into A and B. Any statement at all, as long as it's a true false type of statement, right? It can't be a question, it can't be an exclamation, right? But a true or false statement, if you put it in there, then the argument will end up being valid. Right? Anything for A and B, doesn't matter. You put it in there, it looks like that, then the argument is valid. Right, so that's the general shape. And this format has a fancy Latin name, modus ponens. Okay, so try to remember that. There's going to be a few times where you have to memorize vocabulary. And this is one of those. It sounds like a Harry Potter thing. Modus ponens. I've started to, but I forgot that the textbook does this too, so I really should have done that. You can also call it affirming the antecedents, but let's hold off on that. We'll come back to that, okay? You should know this term, modus ponens. There's going to be another one called modus tollens, right? Very close. And it's just a classic argument format. So it's helpful to just know the name of it, right? So it's a modus ponens. And any modus ponens always has two of these simple statements in it, right? And one of the simple statements is going to be one of the premises, and one of the simple statements is going to be the conclusion, right? You can see that here. Right? And then the other premise is going to be an if-then type of statement that sort of links A to B, right? If you just have an argument that goes A, therefore B, that's one of those situations where you're missing a premise, right? The way that we looked at earlier. Right? So if you just have a statement and then another statement and there's no logical connection, you just insert another premise to create that logical connection. Right? If it just said A, therefore B, there's logic missing. Right? But once you put another premise in there that says if A, then B, then that allows you to do the magic of inference. Then you can say, okay, well, then if A is true, B must be true as well. It must follow. Really quick, by the way, your computers run on logic. Did you know that? The people that developed computing technology were mathematicians and logicians, and they encode the software by using logic. Right? So the computer like knows all these if A then B type of rules. And then when you type something, it's like saying A, right? And then the computer pops something up on the screen, and that's like B. Right? So that if then statement is like a rule, and A is like an input, and then B is like an output. Right? You don't have to know that. Just an interesting fact about logic is that all this technology that we use that we're so dependent on, right? All the online stuff, all the VR, all the AI, all this modern stuff, it all runs on logic, right? This thing that you're learning here. Science runs on logic as well, right? So I can't overstate the importance of logic. So this is a class exercise. It looks like it's a lot, but it's really not. I just want you to come up with 4 arguments with that format, right? 4 arguments that go if A then B, A therefore B, right? But I want you to split it in half. So for 2 of them, I want you to present it the way that you might normally find it, right? Just sloppy sentence format, right? Not the hyper logical premise, conclusion, just the way that people ordinarily talk. Like, if I ever get hungry, I just get a snack. Since I'm hungry now, I'll get a snack, right? That's just ordinary English, just the way that you might find it in real life, right? Or, I must be a wizard. After all, I know magic. And if I know magic, then I must be a wizard. Both of these are ultimately modus ponens, right? They both go if A, then B, A, therefore B, right? Both of these examples are like that. So come up with 2 examples just like that, just written in ordinary English, but that follows the modus ponens format, right? And then for 2 of them, make it look all nice, right? You label the premises, you go premise, conclusion, right? Just like this here, like the classic example. If Socrates is human, then he is mortal. Socrates is human, therefore Socrates is mortal, right? Now, because we're just showing validity, you can just take any statement that you want. Like I said, right? You can just look around you and insert it into that format, right? As long as it goes, if A, then B, A, therefore B. So I can just look around me. If the tree is green, then there are 5 fingers on my hand, right? That's simple, right? If the tree is green, then there are 5 fingers on my hand. The tree is green, therefore there are 5 fingers on my hand, right? That's all you need to do. You can just find any statement and put it into those A's and those B's, because that's the whole point of it. But I just thought that for one of them, let's provide an extra challenge. For one of the ones that you put into premise, conclusion formats, for one of them, actually make sure that both of the premises are true, right? Because then you'll have created your first sound argument. And this is actually, there's 2 core student learning outcomes that are on the syllabus, the official ones that I did not create, that the state created, right? And one of them is construct a logical, coherent argument with a justified conclusion. Well, you will have done that, right? If you do this, you will have hit that part of the core student learning outcome. Okay, so for one of them, just make sure that the premises are actually true. For the other arguments, if they are true as well, that's fine. It does, that's okay. I'm not saying that they have to be false. I just want at least one of them having true premises along with the valid format, the valid modus ponens format, right? And you can make it personal if you want, right? It doesn't have to be scientific or historical knowledge required. It could just be something like, If it's sunny, then I think I'll go to the beach. It is sunny. I will go to the beach. That sort of thing. But try to make sure that it's actually true about you. Right. Okay. Okay, back to argument patterns and modus ponens. Notice that that first statement is an if-then statement, and those get a technical term too. They're called conditionals, and conditionals are going to be really important in propositional logic. Okay, so I'm gonna actually slow down and break down the idea of a conditional really quick. The textbook didn't do that yet, but I'm trying to get you ready for logic. So let's think about conditionals, if-then statements, right? If A, then B. By the way, you can use other letters for the variables, right? Just like in algebra, it doesn't matter. We could also say if P, then Q, or if X, then Y, right? It doesn't matter which one you choose. I'm just doing A, B. So any conditional has this structure to it, right? I know we're getting very, very fine-grained in our thinking here, but that's required for logic, right? We use if-then type of statements all the time. We don't necessarily always think about how they're constructed, right? So we always have the if and the then. We have a first statement and a second statement, right? So the first one is called the antecedent, and the second one is called the consequent. So to help you remember this, right, it's like a mnemonic device. Just think consequent. Sounds like consequence. A consequence is something that comes after. Right? Okay. An antecedent means comes before, but people don't necessarily know that, but people do know the word consequence, right? So just try to remember consequence is the one that comes second, right? Okay. So if we look at the classic, if Socrates is human, then Socrates is mortal. Right? Notice that there's the whole big statement, the if-then statement, the conditional, right? That's one statement itself, but it's a compound, complex statement, right? Because hidden inside of it are two simple statements. Socrates is human. Socrates is mortal. Socrates is human is the antecedent. Socrates is mortal is the consequent. If the original statement had been, if Socrates is mortal, then Socrates is human, which is not true, of course. Lots of things are mortal without being human, so that's not a very good example, right? But if that had been the case, then Socrates is mortal would have been the antecedent, and Socrates is human would have been the consequent. It's just whatever comes right after if is the antecedent, whatever comes right after then is the consequence. Right? If you give me $100,000, then I will eat a live worm. Okay? We're going to use this example later because people have a hard time with the logic of conditionals, but with this example, it's more clear. This, by the way, is true. This is a standing offer that I offer to all my students. If you can get together 100,000, I will, right in front of you, eat a live worm. I promise you that this statement is true. I'd do it for 1,000 probably. The antecedent is you give me 100,000. Right? The consequent is I will eat a live worm. And we can already start to think, right, about the relationship between the truth of the big statement, the compound statement, the whole conditional, right? Is that true or false? And then also the truth and the falsity of the small, little, simple statements. You give me 1,000, I'll eat a live worm. 100,000, right? I'll eat a live worm. Right? The truth of that big statement is going to depend on the truth of those little statements. Right? And notice something very interesting about conditionals. This statement, I promise you, is true. It really is true that if you give me 100,000, I'll eat a live worm. I promise you, that's true. Okay, but notice the small statements individually are not true. You're not giving me 1,000, 100,000 right now. Nobody's doing that. Right? The antecedent is false. Am I eating a live worm right now? No. The consequent is false as well. So in a conditional, even if both the antecedent and the consequent are false, the whole thing is still true. I know that's kind of tricky. It's weird when you think about it, right? But that's just how it works. It's because it's a hypothetical, right? Conditionals are hypotheticals. It's saying if reality was like this, then this other thing would be true as well. Right? It's not saying that the antecedent is true, and it's not saying that the consequent is true. It's just saying that if the antecedent is true, then the consequence would be true as well. So you can sort of visualize it maybe in an if-then statement. It's like the A is pointing to B, right? That's actually the way that we can see it in logic when we use a symbol for the if-then. It's like an A with an arrow pointing to B, right? A leads to B. The antecedent leads to the consequence, right? The truth of the antecedent leads to the truth of the consequence. So if we say, if Socrates is human, then Socrates is mortal, we're saying the fact that Socrates is a human leads us to the truth that Socrates is mortal. That's how the modus ponens works, right? The first premise says A always leads to B. And then the second premise say, well, here's A. Well, what did the first premise say? A always leads to B. So then the conclusion, we can write down B. Right? If we actually use this example, if Socrates is human, then Socrates is mortal. This tells us the fact of Socrates being human is going to lead to the fact of Socrates being mortal. Right? If we accept that first premise, that's our rule, right? And then the second premise says, well, Socrates is human. And then we apply the rule that Socrates is being human always leads to Socrates being mortal. Then in the conclusion, we can make that inference. I know I'm kind of over-explaining it, especially for some people. This will be over-explaining, but I'm telling you, this is good. It's good to be very, very clear about all this stuff before we jump into logic. So I apologize for people for whom it's overkill, but I think it's good to do this. Right? So that first premise says the conditional is true, right? If you say something, you're saying that that's true, right? If I say it's sunny, that's the same as saying I think it's true that it's sunny. Right? So when you say something, you are saying this is true. Right? So when you say if Socrates is human, then he's mortal, you are saying this conditional is true, right? Or this rule is true. Right? And then the second one asserts the truth of the antecedent. The antecedent again is the first part of the conditional, right? Then you can infer the truth of the consequence. Yeah, way over explaining things, getting very, very fine grained. But this is going to help, I promise. So I was saying this earlier, right? The conditional, the hypothetical statement, the if then statement, is a complex statement because hidden inside of it, they're not really hidden, they're just there. But it's composed of multiple simple statements. Right? So we can color code them to make this 100% clear, right? Yes, there's one big statement. If you give me 100,000, then I will eat a live worm. That's one big statement. That statement is either true or false, right? It's a statement. It can be true or false. But then there's also the statement, you give me 100K, and the statement, I will eat a live worm. Those also can be true or false. A quicker way to say that is that they have truth values, okay? So I might say that sometimes. So try to remember when I say it has a truth value, it means it could be true or false, right? So the conditional has a truth value, and both of the simple statements have truth values. And the truth value of the big statement depends on the truth value of the little statements. So, we could let's test this out, right? Let's say against all odds, this summer class, you get together with the rest of your classmates and you say, let's actually do this. Let's raise 100,000 so we can see our professor eat a live worm, right? Let's say you actually do it and you present it to me. You come to my house and say, here it is. Here's your 100K. And then I don't eat the worm. Well, then it means that I was lying, right? That means the statement was not true, right? Uh, I am telling you right now that it is true. If you give me 100K, I will eat a live worm, right? Uh, and so if you give me the money and I eat the worm, it just confirms it, right? But if you give me the money and I don't eat the worm, then I lied to you, right? Then the rule is false. Then this statement is not true, right? In fact, that's the only way for this statement to be false. And this is also getting us ready for logic, because this is the part that trips people up about conditionals. Right? A conditional is only false in one scenario. It's only false when the antecedent is true and the consequent is false. Right? That's the only thing that would make my promise not be true. Right? If I say, you give me 100K, I'll eat a live worm. You give me 100K and I don't eat it, then I broke my promise. But if you give it to me and I do eat it, I did not break my promise, right? If you don't give me 1,000 and I don't eat a worm, I still didn't break my promise, right? That's the situation we're in right now, right? You're not giving me 100K. I'm not eating a live worm. That is reality. That's the truth, right? Both of those statements are false. But the whole statement is true. The conditional is true. Because if you gave me that 100K, then I would eat that live worm. And notice that there are just 4 logical possibilities here, right? And that's going to come up in logic as well, right? Uh, the antecedent and the consequent could both be true. The antecedent could be true, but the consequent is false. The antecedent could be false and the consequent is true, or both the antecedent and the consequent are false. Right? There's 4 logical possibilities, but only in that logical possibility where the antecedent is true, you give me 100,000, and the consequent is false, I don't eat the worm. Only in that scenario is the conditional false. We will return to this. I just like to sort of, prepare you for what's ahead. So this is one of the things that we're going to think about when we do logic. Here's one that's not with a conditional, right? That still has 2 simple statements, but I'm joining it with an and. In logic, that's going to be called a conjunction, an and statement. Work is done and I am ready to party. Right? If I say that, then that whole big statement can only be true if work truly is done and I truly am ready to party. Right? If I say it right now, maybe the ready to party part is true, but the work is done part is not true, because here I am working, though it doesn't feel like work. This is fun for me, like I said. So work is done and I'm ready to party. That is also a complex compound statement because it's composed of multiple statements. But for that, the rules are a little bit different, right? For that, both of the things you're saying have to be true. Both of the simple statements have to be true. If either one of them is false, or if they're both false, then the whole thing is false. Again, there would just be 4 logical possibilities, right? Either work is done and I'm ready to party. Either they're both true, or work is done but I'm not ready to party, or work isn't done and I am ready to party, or work is not done and I'm not ready to party. Right? 4 logical possibilities when you have 2 statements together into a complex statement. Right? That gives rise to 4 different possibilities. We can make other valid arguments using a conditional as a premise. Think about this one. Okay? If there is a cat nearby, then Jojo will sneeze a bunch. Since Jojo isn't sneezing a bunch, that must mean what? There isn't a cat nearby. Again, I hope you could just have that innate sense of logic that says, yeah, that makes sense, right? If there was a cat, there would be sneezing. There's no sneezing, so there must not be a cat. Right? That makes sense. That's logical. It's valid. Slightly more academic version of this, right? The Romans never practiced mummification at a large scale like the Egyptians. If they had, there would be lots of physical evidence of it, but we don't have it. We don't have that evidence, right? So it's basically saying there would be all sorts of archaeological or textual evidence if this was ever adopted at a wide scale like the Egyptians, right? We would find that. We didn't find any of that, so they did not practice it at a large scale, right? The same logic as the cat example that I just gave. It's the same type of thing. It says, if this, then this, but not this, so not this. Go back to the free will and determinism. Right? Determinism is the idea that every single event is caused by previous states, right? And that kind of seems like it's right, but then philosophers get worried because what does that mean for free will, right? Well, you could also state it like this, right? You could go, if determinism is true, then every event is completely determined by prior causes. But you know what? Not every event is completely determined by prior causes. And you could support that premise, right, by appealing to free will. I could say, it's completely up to me which hand I raise right now, right? Nothing is forcing me, I'm not being determined. It's up to me, right? You could say that argument. I'm not saying that that's right or wrong, but you could support premise number 2, and then it would follow logically that determinism is not true, right? Same format, same basic idea. If A, then B, not B, therefore not A. Really simple example, just intuitive, hopefully, right? If it rained, the porch would be wet. The porch is not wet. Right? So it didn't rain. It follows logically, if both of those premises are true. Now, I just wonder if sometimes people look at an argument like this and they think, yeah, but what if the rain dried in the meantime, right? Well, then premise number one wouldn't be true, right? If you're saying there's an exception, if you're saying that maybe it rains and the porch isn't wet now, then you're just saying premise 1 is not true, right? So it's a valid thing, it's a legitimate thing to bring up, but you're not really assessing the validity then. You are having a problem with one of the premises, right? If both of these premises truly are true, then that conclusion does follow, right? If you want to say, well, sometimes it rains, but it doesn't hit the porch, or sometimes it rains, but it dries really quick, right? Then you're just saying premise 1 isn't totally accurate, right? Then you're addressing the truth question. The validity question, the logic question asks, imagine that these premises are absolutely true and there's no exceptions, then what follows? Then it would follow that it didn't rain. I say they all look like this, right? The first premise is exactly the same. It's a conditional, if A, then B. But then that second premise denies or negates the consequence. Right? So the other one affirms the antecedent, right? For modus ponens, we saw that the second premise says A. And so that's affirming the antecedent of the conditional. For this argument format, we are denying, right? We're saying that something isn't true. We're denying the consequence of the conditional. So the format basically says, hey, if statement A is true, then statement B must be true. But statement B is not true. So statement A must not be true, right? Or again, you could think of it as one thing leading to another, right? A always leads to B, but I don't see any B around, right? So A must have not happened. So again, for the modus ponens looks like this, right? Just to refresh your memory, the previous one we looked at, modus ponens, goes, if it rained, then the porch would be wet. It rained, therefore the porch is wet, right? It affirms the truth of the antecedent. Remember, the first part is the antecedent, the second part is the consequent. That second premise there affirms, it says yes to the antecedent. And then that allows us to make the inference that the consequent must be true. Just to remind you, right? The first statement is the antecedent, the second one is the consequent. But in this format, modus tollens is what it's called, right? Where we go, if A, then B, not B, therefore not A, which would look like this, right? If it rained, then the porch would be wet. The porch isn't wet, therefore it didn't rain. That second premise there is denying the truth of the consequence. Right? The consequence of the conditional says the porch would be wet. Premise 2 denies that. It says the porch isn't wet. And then that allows us to infer that the antecedent was false. Right? So that's how all modus tollens works. You have a conditional with an antecedent and a consequent. Then one of the premises set denies the truth of the consequent, and then we can infer that the antecedent must be false. Right? Again, when we state a premise, we are saying that that premise is true. Right? So premise number 1 asserts the truth of that whole conditional. It says, here's the rule, right? Conditionals are kind of like rules, right? Whenever this, right? Here's the rule. When it rains, porch gets wet. That's the rule, and it's a true rule, right? I'm stating it as true. And then the second premise says that consequence, the porch would be wet, is false. Right? The porch isn't wet. We're denying the consequence. And then in the conclusion, we can infer that the antecedent, it rained, must also be false. We say it didn't rain. Okay, so that's modus tollens, right? Where that second premise negates or denies the consequent of the conditional that you just stated in premise 2. Now here, okay, now pay attention. Here it can get a little bit tricky for sometimes, and I don't think the book really explains this, but I want to make this very, very clear. Sometimes that consequence is itself a negative statement. And so when you deny a negative statement, what do you end up with? A positive statement, right? If I say it's not sunny, and you deny that, you say that's not true what you just said. Well, what you're saying is that it is sunny, right? So when you deny a negative statement, you end up with a positive statement. So let's look at an example, right? If this is our conditional that we're going to start our argument with, right? Let's suppose if the suspect was at the scene of the crime, Then the suspect was not at Club Aqua, right? So we're imagining a court case, right, where at a certain time, right, if the suspect was at the scene of the crime, then they could not have possibly been at this club, right? Some people will know the reference here. Then the suspect was not at Club Aqua, right? There, that consequence already has a negation, right? It already says not, right? It's saying the suspect was at Club Aqua. No, he wasn't, right? The suspect was not at Club Aqua. So it's already negative. So then when that second premise comes around to try to deny it, right, we're going to have to turn into a positive. Right? The second premise denies the consequent, right? If there's a cat that I'm sneezing, I'm not sneezing, so there's no cat. Here we have the same structure. If the suspect was at the scene of the crime, then the suspect was not at Club Aqua. Then when I deny that, I'm going to say it's not true that the suspect was not at Club Aqua, right? Because that's the statement being denied. Maybe again, way over explaining it, maybe, but some people I know from experience need this. Right? So in a modus tollens, the second premise is going to always deny the consequence. The consequence says the suspect was not at Club Aqua. So we're going to deny that. So they are not at Club Aqua, which means they are at Club Aqua. Right? The negatives cancel out. It's again like try to think of another easy example. If I had taken my allergy medicine, then I wouldn't be sneezing. How would I negate I wouldn't be sneezing? I would negate that by saying I would be sneezing. Okay. So then the argument would go, if I had taken my allergy meds, then I wouldn't be sneezing. I am sneezing. Therefore, I must have not taken my allergy meds. Right? Same type of thing. So this is probably not confusing for a lot of people, but sometimes can be confusing, right? Okay. So this is the argument that you would end up with. This would be the modus tollens, right? If the suspect was at the scene of the crime, then the suspect was not at Club Aqua. Let's deny that the suspect was not at Club Aqua by saying the suspect was at Club Aqua. Therefore, the suspect was not at the scene of the crime. So that second premise doesn't say the word not, right, like it does in the format, but it's still negating something. That's what's important here. It's also possible that I'm just confusing people by going into detail. That's also a possibility. But this whole argument here follows modus tollens completely, right? The first premise says the conditional is true. The second premise denies the truth of the consequence. The truth of the consequence said the suspect wasn't at Club Aqua. So if we're going to deny that, we have to say the suspect was at Club Aqua. It's hard to say over and over. And then the conclusion infers the falsehood of the antecedent, just like the previous ones we looked at. Let's use one more example here, a philosophical example, just to make this clear. If every event is determined, then we have no free will. We do have free will. Therefore, not every event is determined. You could use this argument as a sub-argument for that previous one. Don't worry about that. Here, we should notice that this is still a modus tollens, right? Even though, if you look up, the format says if A then B, not B, therefore not A. And if we look at this argument, Premise 2 just says we do have free will. It doesn't have a not, but it's still saying not to the consequence. It's saying we have no free will. We do have free will. Right? So the second premise always denies the truth of the consequence. The consequence says we have no free will. So to deny that, we have to say we do have free will. And then we can infer that the antecedent must have been false. Okay, so I hope that makes that clear. Sometimes it's going to happen like that, right? So I just don't want you to think that a modus tollens, the second premise, is always going to say that something isn't the case, right? Because if it's denying something that isn't the case, then it's going to say it is the case. Okay. So just something to keep in mind. Here's another valid argument form, right? So those are the two basic ones where we start with a hypothetical, conditional, and then we either assert or deny the antecedent or the consequent. And of course, if you're thinking logically, you'll realize that there's still two possibilities that we haven't looked at, right? We haven't looked at, well, what happens if the second premise denies the antecedent? Or what if the second premise affirms the consequence? We will look at those later. Those are invalid. Right? Those are not valid argument forms. So right now we're just looking at valid ones. The other two possibilities, if what we're doing is looking at the first statement and the antecedent and the consequent, we can either affirm or deny, right? Either one of them. The modus ponens affirms the antecedent. The modus tollens denies the consequent. But you still have two other possibilities, right? You could deny the antecedent instead, or you could affirm the consequent instead. Those are both not valid argument forms, so I'm not including them here for that reason. But this is valid, right? If A, then B. If B, then C. If both of those premises are true, then we can infer if A, then C, right? If A always leads to B and B always leads to C, then we know if we have an A, it's going to eventually lead to a C. Right? But here we've introduced a third variable, right? Here are just three simple statements. Right? We have an A, a B, and a C. You cannot make a hypothetical syllogism work with just two simple statements, right? Modus ponens and modus tollens, they have exactly two simple statements because it goes if A, then B, A, therefore B. It has to have two simple statements, and that's it. This has to have three, right? That creates another problem thinking logically through it, because when you have two statements, we just have four logical possibilities for how they can be true or false together, right? One of the statements could be true and the other one false, or that one's false and this one's true, or they're both true or they're both false. But if you have three statements, then suddenly you have 8 logical possibilities, right? And every time you add another statement, it doubles, right? So if you have 4 statements, that's 16 logical possibilities. If you have 5, that's 32, right? That'll all become more relevant later when we start doing logic. But so here's just a kind of a silly, just everyday kind of an example, right? And remember, a lot of these examples are not actually things that would be an argument in real life, right? Kind of some of these are kind of silly, but they're just here to show the logic, right? And the logic is there, even if the examples are not realistic. If I get a car, then I need money. If I need money, then I need to get a job. Well, what follows? Well, if I get a car, then I need to get a job. Right? It just follows logically. And like modus ponens and modus tollens, right, this argument format is always valid. You can plug anything into those A's and those B's and those C's, any statement you want at all, it will be valid. Whether or not it's sound, right, that's going to depend on whether or not the premises are actually true. But it will at least be valid, right? The logic part will check out. But if the premises are true, then the conclusion must be true. And there's different ways to say that, right? That this all describes what validity is, right? The conclusion logically follows from the premises, we could say. Or the truth of the premises guarantees the truth of the conclusion. Or the conclusion could not possibly be false if the premises are true. And these are all different ways of saying what validity is. And hypothetical syllogisms are always valid. Anything that's valid is always valid, I should say. Right? It's almost redundant to say always valid. If there's an argument format and we know that it's valid, then you could always plug in other statements instead and it'll still be valid. Now, technically, you'll figure this out when you do logic. There's an infinite amount of valid argument formats because they can get very, very complex. Very, very complicated arguments can be valid with all sorts of stuff happening, with all sorts of internal things that are very complex. But we don't bother labeling all of those, right? We kind of label the main ones that we really use, the most basic ones. And a lot of times the more complicated ones end up just being a complicated version of one of the simple ones. So really, for our purposes, we're just going to have 4 argument formats, valid argument formats that you have to remember. And so we've learned 3 of them, right? We've got the modus ponens, modus tollens, hypothetical syllogism, and then we're going to look at the disjunctive syllogism. So that's just 4, right? That can't be too bad, right? Just 4 valid argument formats that you should get into your mind, get into your head, know what they are, be able to recognize them, right? And that can help you actually construct your own arguments, right? And it can also help you determine whether or not an argument is valid just by looking at it, just by looking at the structure, right? After a while, you'd be able to say, oh, okay, that person is presenting me with a modus ponens. Okay, so I know the logic question is taken care of. Now let me just focus on, are the premises actually true? So that's shouldn't be too bad, right? 4. You can learn 4. So here's the 4th one, the last one. This one does not use conditionals, right? It uses an or statement, right? Or statements are called disjunctions. And so this type of argument is called a disjunctive syllogism, right? It sounds like an I problem. Either A or B, not A, therefore what follows logically, B, right? Here's basically eliminating alternatives, right? That sort of a thing. Like, well, I know one of these things is true. Well, this one is definitely false. Leaves us with this one, right? That's a logical move, right? Hold on 1 second. One of my kids is already back. I'm going late. Okay, no, it's all good. I can finish up. Okay, so no conditional here. We're using an or statement. So just as a example, wait, what happened here? Did I? Yeah, I messed up there. Let me go back here. So we're using an or statement. So far, you've actually learned 2 of the major operators that we use in logic. Remember, I'm trying to get you ready for logic. The operators, like in math, you have like plus or multiply, right? Those kinds of things. They're symbols that do something, right? We have the same kind of thing here. We have if-then operators. That'll be like an arrow. And then we have the or operator, right? And the operator helps us figure out what the truth of the big statement is, right? Depending on the truth of the simple statements. If you don't understand what I just said, that's okay. We'll unpack that more later, right? But yeah, if, then, and or are both going to be these kind of logical operators that we're going to use, similar to how you have operators in math. Notice if you have two simple statements, A and B, right? If you say if A, then B, then there's a certain situation where that's going to be true or false, right? We looked at the only time that that's false is when A is true and B is false, right? If you have A and B, then there's a different rule, right? Then they both have to be true for the big statement to be true. And so the work there has to do with the if-then operator versus the disjunction, the or operator. Again, if that wasn't totally clear, we will make that crystal clear later on. Okay. So here's just an everyday example. Right? Either the internet outage is caused by my router or my problem is with the ISP. Right? If I know that ahead of time, and then I go, okay, well, let me check, let me do some diagnostics. Oh, okay, well, I just ruled out ISP issues. Well, then it's got to be the router, right? That's an everyday practical reasoning kind of an example. Right? It also makes me think of, if you're doing a multiple choice test where maybe there's more than just two options, right? In the disjunctive syllogism, you have just two options. But if you're doing a multiple choice test, sometimes you don't know the answer, but you kind of go, well, that can't be the right answer. That can't be the right answer. And you end up guessing correctly, not because you knew the correct answer, but you knew which ones were the wrong answers and you eliminated those. That's sort of what we're doing here, right? When you're not sure what the answer is, but you can eliminate an answer, and that leaves you with the correct answer. Okay, so these are our 4 argument formats that I want you to remember. Right? Actually memorize these, study these. This will be on the quiz. This will be on the midterm. Right? You need to know these for us to be able to start doing logic, which we're going to jump into probably next time. So just try to remember each of these, right? The modus ponens, if A then B, A therefore B. And notice that the alternative title for that is affirming the antecedent, because that's what the second premise is doing, right? The first premise is just a conditional. And a conditional, remember, has an antecedent and a consequent. The antecedent is the first part right after if. The consequent is the second part right after then. Right? Well, that premise there, premise 2, says A. It is affirming that the antecedent of the conditional is true. Right? Modus tollens denies, right? But it denies the consequent. It denies the second part, the B part, right? The second premise is not B, right? It denies the consequent. Right? And then we have the hypothetical syllogism, right? Where A leads to B, B leads to C, and C leads to, and then A therefore leads to C. And then the disjunctive syllogism, A or B, not A, therefore B. Right? Okay, so memorize all those, and then your final exercise is this. You can use this right here, and again, you can come up with any kind of statements to put into the A's and the B's, right? You don't have to worry. So this really should not be difficult at all, because you can literally just look around the room. The table is brown. My mouse is shiny, right? Okay. If the table is brown, then my mouse is shiny. The table is brown, so my mouse is shiny. That can be it. It's very easy. You just look at the format and plug in some statements, right? So do that for each of them and do 2 of them. But I want you to practice that tricky thing that we talked about, right? For the modus tollens, where the second premise denies the consequent, I want that consequent to already be a negative statement, so that when you deny it in the second premise, it turns into a positive statement, right? So like the 2 examples that we looked at, or the example that I just came up with, right? If I had taken my allergy medicine, then I would not be sneezing right now. What's the consequence? I would not be sneezing right now, or I am not sneezing right now. If we deny that, like we do in a modus tollens in the second premise, then we're going to say, I am sneezing right now. Now, you don't want to say, I'm not sneezing, right? That's ultimately what it is, but negations cancel each other out, right? So You could even think of it that way, right? Let me just run you through this and then we'll be done, right? Let's think of it this way. If I take an allergy medicine, I would not be sneezing right now. Second premise. It's not true that I would not be sneezing right now, right? It's not true that I'm not sneezing right now. Okay, let's simplify that and just say I am sneezing right now, right? Okay. So for one of them, you do that, right? Everything else doesn't matter. Doesn't matter if the premises are true or false. I don't care about that for this part. You can do that if you want, but it doesn't matter. Okay, thank you so much, Janice and Yvonne. I very much appreciate you being here. It makes it so much better for me. Uh, thank you. And I don't know if you have any questions or not. Otherwise, I'll see you soon. All right, I'm going to stop recording.